Alright guys, in this video we're going to talk about how to use properties 4, 5, and 6 from section 6.5. I'm not going to go through the explanation on why they work, just know that they come from exponent rules, and if you get somebody's notes they should have the explanation in there. So property number 4 says that the sum of two logarithms is the same as a logarithm of a product. Okay, so we can combine the sum of logarithms as a product, or in the reverse, we can take a product and make it into a sum. Okay, so sum and a product go together. So for example, if we have log base 2 of x plus log base 2 of 5, we could combine these together. It's a sum, so we can put it together as one logarithm, log base 2 of x times 5, or 5x. Okay, if we have something like log base 3 of x times x plus 4, okay, that's a log of a product, x times x plus 4. We can break this up as log base 3 of x plus log base 3 of x plus 4. Okay, and then remember the sum or difference inside of a logarithm, we can't do anything with that, so we stop right there. Alright, so that's the basic idea for number 4, going from a sum to a product and a product to a sum. Notice that when you do that, every single term gets a logarithm and the bases have to match. Alright, so let's look at property number 5, going between a difference and a fraction. So a difference of logarithms is the same as division inside of the logarithm. So let's say we have natural log of 5 minus natural log of y. So you see that subtraction and you think, okay, that goes together as division. So it'll come together as one natural log of 5 over y. 5 over y. Okay, and if we have, let's say we have common log of let's say 3 over x, common log of 3 over x, we can break that up as log 3 minus log x. Okay, so if you have a fraction, you can break it up as a difference, and if you have a difference, it can come together as a fraction. So that's the basics for number 5. Okay, looking at number 6, this tells us that an exponent inside the logarithm is the same as a coefficient in front of the logarithm. So for example, if we have log base 2 of x to the 5th, log base 2 of x to the 5th, we've got an exponent inside the logarithm, so we can bring that down to the front of the logarithm. So this is the same as 5 log base 2 of x. So two things to notice with this. One, the exponent has to go to the whole thing. And 2, when it comes down as a coefficient, it comes down in front of the logarithm, not inside of the logarithm. Okay, so those are two common mistakes with this one. So let's say we have natural log of y to the 4th. Natural log of y to the 4th, that's the same as 4 natural log of y. Okay, and vice versa, if we have a coefficient, let's say we have 2 log base 4 of x, okay, we can also bring that up as an exponent. Okay, so this coefficient of 2, we can bring that up and get x squared inside the log. Okay, so we can go back and forth between exponents and coefficients. Now be careful with this. Alright, let's say we have natural log of 4x cubed. Okay, can I bring that exponent down? And the answer is no. You have to remember your order of operations. The exponent only goes with what it's next to, unless there are parentheses telling you otherwise. So this exponent only goes with the x, it doesn't go with the 4. So that means this exponent doesn't go with the whole thing. Has to go with the whole thing for rule number 6 to work. But what we can do is we can break this up. This is 4 times x cubed, and we know that we can go from a product to a sum, so let's do that. So we get ln 4 plus ln x cubed. Okay, we know we can go from a product to a sum. Now we can simplify this exponent. So now we can bring the exponent down to the front because it goes to the whole thing. So we get ln 4 plus 3 ln x. Okay, so just be careful with those exponents. Make sure the exponent goes to the whole thing before you bring it down to the front. All right, so let's come back over here and let's put these rules together to try to solve a few. All right, so let's say we have natural log of x to the fifth y over z squared. Okay, natural log of x to the fifth y over z squared. So let's look at all the stuff we have going on here. We've got multiplication, because we've got x to the fifth times y. We've got a fraction, so we've got over z squared. And we've got exponents. We've got x to the fifth and z squared. So we've got 4, 5, and 6 all going on here. We've got product, division, and an exponent. So how do we attack this? Well, first ask yourself, can I do anything with those exponents? Do the exponents go to the whole thing? And the answer is no. So I can't do anything with the exponents first. But I can do the product and the division. I can use rules number 4 and 5, and I can do those at the same time. Okay, like order of operations as they go, they're the same thing. So we can go ahead and break up the product as a sum and the fraction as a difference. So we get ln x to the fifth plus ln y, okay, that's breaking up this product right here. And then remember, division means subtraction, so we'd have minus ln z squared. Okay, so the product becomes a sum and the fraction becomes a difference. So now we've got natural log of x to the fifth plus natural log of y minus natural log of z squared. All right, so we're in good shape so far. Now can we do anything else? Well, when we look at this, now we can get to these exponents. Now the exponents are by themselves. So we can go ahead and bring the 5 down to the front, and we can bring the 2 down to the front, and that natural log of y, we can't do anything with that. So we get 5 natural log of x plus natural log of y minus 2 natural log of z. And we just want to double check, do we have any more products inside, any more fractions, any more exponents? No, we are completely done with that one. So that one's good. All right, let's try another one. Let's say we have log base 2 of 8 a to the fourth over b plus 1. Okay, so we've got 8 a to the fourth over b plus 1. All right, so what do we have going on here? Well, again, we've got an exponent, we've got multiplication here between the 8 and the a, and we've got division over b plus 1. Okay, so can we get to this exponent? Does the exponent go to the whole thing? No, we'd have to have parentheses around it for it to go to the whole thing, right? So it only goes to the a. So we've got an exponent, but we can't get to it yet. But we can do the multiplication and the division. So let's go ahead and do that. So we get log base 2 of 8. Remember, product goes to addition. So we're going to have log base 2 of 8 plus log base 2 of a to the fourth. And then division, fraction, goes to subtraction. So we'll have minus log base 2 of b plus 1. Let me write that a little bit better. b plus 1. Okay? And we need those parentheses around that because we don't want it to look like log base 2 of b and then plus 1 separate. Okay, so product to addition and fraction to subtraction. So we broke all of that up. Now let's look and see if we can do anything else. All right, log base 2 of 8. Can we do anything with that? Well, we know from the last section, if we can get the bases to match, then we can get this to simplify. So can we get these bases to match? And the answer is yes, we can. We can write 8 as 2 cubed. All right. So let's go to we know that we can keep simplifying that. Let's go to the next one. Can we do anything with the well, we'll go ahead and finish this one up. Let's finish our thought. Okay, so if the bases match, remember if the bases match, then the answer is just the exponent 3. So log base 2 of 8 is the same as 3. So we simplified that all the way down. All right, now let's go to the next one. Log base 2 of a to the fourth. Can we do anything with this? Well, yes, now we can bring this exponent down to the front. And we've got 4 log base 2 of a. There's nothing more we can do with that, so we'll just carry that down to our answer line here. And then this last one, log base 2 of b plus 1. There's no exponents, and remember, we cannot do anything with a sum or addition, a sum or difference inside of the logarithm. Okay, so if that's inside the log, there's nothing you can do with it, you leave that alone. Log base 2 of b plus 1. And we'll just carry it down to our final answer at log base 2 of b plus 1. So if you see a sum or difference inside of the logarithm, do not try to simplify that. Okay, and there's our final answer. We got rid of all of the multiplication, all of the fractions, and all of the exponents that we can.